Uh, Thank you everyone for coming to today's SFPE Hong Kong Student Chapter webinar. And we have a great pleasure today to invite one of my old good friend and also previous lab mate back in Imperial College. Is Dr. Isabella Vermesi. And uh, let me do the short introduction. So uh, Isa yes, got his PhD, her PhD from the Imperial College, and we have the same supervisor, is Professor Guillermo Rain, and she graduated from 2017 and moved to the industry, work as a fire engineer. And I think she's in charge of the fire engineering team with member more than 30 engineers. And I also had a great pleasure to present some of my research to your team. And I can feel it's definitely one of the most active fire engineering group in UK, if not in Europe. Okay, so now the floor is yours.
Yeah,
Welcome.
thank you so much for that glowing introduction. I will share my screen. Let me probably I only have one screen, so I probably won't see you guys after I do this. Is that correct? Oh no, Zoom is more advanced. I use Teams all the time, so that's fine. Okay, yes, here it is. Yeah,
Looks
thank you very
good.
much for. Yeah, looks good. Thank you. Excellent. Thank you so much for making the time to come to my talk today. I know it's quite late. It's a Friday evening, so I really appreciate that you're curious about fire engineering in the UK. Also, I think you might. Okay. Do you guys see this? Do you see this little tab with the names and everything?
Yes, we can see it.
Yeah. Okay. Well, let me make it smaller so you guys can see the presentation. All right. So, as Sinan said, I've got a little profile here about myself, but I'll go quite quickly through it because the main points were that I did a PhD with Professor Guillermo Rain on computational pyrolysis and ignition of solids. That's where I met Sinan, and it was back in 2014, a long time ago. Graduated in 2017, and then I got into the fire safety industry because I was very curious about working in the design world essentially. So I joined Bureau Veritas in 2018 as a graduate fire engineer, and in 2024 I became the head of the team. Currently we're on 30 engineers, and yeah, when I joined we were 7. So we've grown a lot in the past 6 years. So yeah, we've got a really dynamic and exciting team. I will talk very briefly. Oh yes, and currently I'm submitting my chartership application to the Institution of Fire Engineers. That's where I'm at in my career in general. I'll keep it quite brief. I'll give a brief introduction of Bureau Veritas as well, and then I will move on to my the main topic of today, which is fire engineering in the UK. This little abstract that I sent had some I noticed quite some big judgments on the state of fire engineering in the UK today. I think the talk is a bit more toned down because I felt like giving the judgments without giving you guys the proper background and understanding of what is the basis of fire engineering and legislation and everything in the UK is a bit unfair. So it might make things seem worse than they actually are. Or maybe it will be realistic. I don't know. Let's see how it will go. So yeah, Bureau Veritas is a global company of testing, certification, and inspections. You may have seen the stamps of Bureau Veritas on lifts or other areas that have been inspected and certified. It has, these are some brief numbers about the revenue. It's got over 80,000 employees all over the world, over 400,000 clients, and there's many labs and offices around 140 countries in the world. Within the UK, Bureau Veritas has dealings in the mechanical sector, certification sector, and also in the construction sector, where we, the fire engineering team, sit. And come on, slide, move. Where's my slide? Okay. yeah, here it is. And in the construction industry in the UK, our fire engineering team, 30 people, works on a very large number of sectors. I have a feeling that you guys don't see this very well. These sectors range from schools, residential, prison and custodial, defense, student accommodation, a lot of data centers recently. That's been one of the big sectors that we've had in the past few years. Offices, especially office refurbs. If you think about London, there's a lot of old buildings that are used as offices and they need to do internal refurbishments and have their own challenges in terms of listed status or achieving modern standards of safety. We also work in the hotel sector, in the health sector. So really, rail, I forgot to say that. We have a lot of projects with network rail and train stations, whether it's just adding a lift to make the station be accessible or a full new station or a full station refurbishment. So quite a large variety of things that we work on. So yeah, this was a brief intro into my team, Bureau Veritas, and how we're, why is Zoom asking me all of these things? I don't know. Yeah, so now, as I said, I wanted to do, before I set off into the conclusions of where we are as a fire engineering industry in the UK, I wanted to set the scene. And I think it's quite an unusual setup what we have in the UK. And I compare that mostly with, I think, the US and Australia. Those are the ones that I'm, and some countries in Europe. That is what I'm mostly familiar with. There might be other places that do it differently. I'm not sure how it is done in Hong Kong. So I'm curious if after this talk, you have some questions or you want to share how things are done in Hong Kong. I'm very, very curious. So please feel free to contribute. So essentially, in the UK, the main piece of legislation that deals with buildings is building regulations. And the fire safety part of building regulations depends on each of the countries in the UK. So each of the countries in the UK have their own local governments. And when there's things like immigration, defense, things like that, there's obviously the centralized government that has its own regulations. When it comes to things like health and safety, education, each of the local governments has a bit more independence. So in Northern Ireland, there's the Part E of the building regulations. In England and Wales, which is what my talk is going to be focused on. By the way, I don't see the chat right now, so feel free to interrupt me if you want to say something. If not, I will read the chat after, because as you can see,
I muted everyone so they cannot
you mute. Oh, okay,
so
okay,
they will
okay.
leave the message there.
Okay, great. So I'll read the messages at the end. Thank you very much. I will focus my talk today on England and Wales because that is the bread and butter of what we do. So most of our projects are in England and Wales. We have a lot in the rest of the UK as well, but on a daily basis, this is what we deal with. So yeah, the Part B of building regulations is the law that you have to comply with. And this looks at requirements B1 to B5. So B1 is means of warning and escape. B2 is internal fire spread linings. B3 is internal fire spread structure. And then B4, external fire spread, and B5, firefighting facility. So these 5 are the 5 regulations that you have to comply with. This is the law. Nothing else is the law, just these 5 things. And then there's also 2 more regulations that are very relevant for England and Wales, which is Regulation 38, which comes after a building is complete, and you have to declare that the building that you've produced, designed, and constructed is fire safe. And then Regulation 7, which deals with materials and workmanship. So what kind of, if you can use combustible materials or not, what's the level of workmanship that you have to do? So basically in line with manufacturer installation guides and, not everybody doing whatever they want. So this is for England and Wales. For Scotland, Isle of Man, Channel Islands, they have a bit different building regulations, but they're different, but also quite similar. So they're not like vastly different. So when you think of, I'm just thinking in my head, comparing it to the US, where you've got the NFPA guidance, the NFPA standards. Those standards have many, many pages and essentially tell you in great detail what you have to do to comply with the law. And that's what, when you think of prescriptive design, that is what you think of. Now, in the UK, I've provided some snippets here of, I mean, these are not snippets, these are deregulations. So this is not a copy paste that is, sorry, a snapshot that is summarizing or anything. No, this is all it is. So the regulation, part B1, means of warning at escape, it's literally just this. This, what you see here. Buildings shall be designed and construction, so they're appropriate provisions, and then appropriate means of escape. Then internal fire spread, adequately resist. You see all of these words that, you know, what does adequately mean? What is an appropriate provision? The same if you go further in the structure. Its stability will be maintained for a reasonable period. So this is the same. Wait, what have I done? Oh yes, this is the external fire spread. Exactly. The external walls of the building shall adequately resist the spread. So these are these words that are not prescriptive. So adequately, reasonable, appropriate, these all imply a judgment. Now, a person without knowledge, a person that is not competent and doesn't understand fire, cannot make a judgment on something that they're not trained on. So essentially, the regulations in the UK would suit themselves more for a performance-based kind of approach rather than a prescriptive approach, because a prescriptive will tell you need to have sprinklers, you need to provide automatic detection alarm, you have to do this, this, and this. In the UK, the building regulations tells you have to provide reasonable things, appropriately resisting. So this is key. That's why I'm highlighting it so much, because this is the crux of why we are where we are today. This implies that fire engineers and the industry is very educated and competent in fire safety and understanding the consequences of utilizing certain materials or others. So this is building regulations. Now, how do you demonstrate that something adequately, you have appropriate provisions, it's reasonable, it's adequate? How do you demonstrate that? So there's a few ways to do that. You can either utilize local government technical guidance documents. So maybe you've heard of them, if you've heard about the Grenfell Tower fire and whatever other things are happening in the UK. You have these guidance documents, approved document B, which is done by, it's produced by the government. You see the cover here, it's produced by the government. Then you've got other technical booklets for Northern Ireland, Scotland's technical handbooks, which are incredibly confusing and clearly not written by engineers. You can use these to demonstrate that, okay, my building, my design is in line with this. So whatever approved document B says, for example, you shouldn't have an exit width below, I don't know, 800 millimeters. You should have structural fire resistance of 60 minutes. This is in line with approved document B. Therefore, this is the way that I've used to demonstrate compliance with building regulations. If you don't want, or you can't use approved document B because your design doesn't fit in the magic numbers that you have in approved document B, you can use a more advanced approach using the British standards. So the British standards, typically the ones that we use are 9999. In common speech, that would be 9999. And you have also BS 9991 for residential buildings. So essentially what these standards, what 9999 does is it looks at the use of the building, whether it's used by the public or whether it's used by people who are very familiar with the building. And also looks at the fire growth, fire load and fire growth. So if you have, for example, a warehouse that stores combustibles, that will have an ultra fast fire growth. So that will inform the risk profile that you're using and tell you the more onerous measures that you have to put in your building. Whereas if you have, let's say, an office where you just would have office supplies, printer, and some chairs and some screens, then that is considered less of a fire risk. So you can also use that. If you have a complex building, say, I don't know, a new theater, a new stadium, or something that doesn't really work with these standards, you can do a full performance-based design utilizing the framework of British Standard 7974. And that has multiple sub booklets where it deals with things like evacuation calculations or ignition and time to evacuation, things like that. But when you think about, so these are all ways to demonstrate compliance. It's very valid. If you want to do a full 7974 approach, that's okay. But a lot of the times, people confuse these guidance documents with the law. So they think that you have to comply with approved document B, otherwise you will not, you're breaking the law, which you're not. And one of the things that I wanted to highlight, and this might be hard to imagine, is that these guidance documents applicable for in the same country, let's just take England, approved document B, and then British Standard 9991, have contradictions between each other because they have been updated in light of events in the Grenfell Tower fire. Approved document B has been updated in 2022, and then it's been updated last year with amendments for 2026 and 2029. While at the same time, BS 9991 was updated by other people because they're different entities. So the British standards are done by the British Standard Institute, and then the approved documents are done by the government. So they have different panels. Maybe there's some people that are in both. I'm not entirely sure because I don't know exactly who is in these panels, but they're different. So British Standard 9991 came out after the ADB amendments, and they have parts in which they're actively contradicting each other. So this leads to an environment of confusion. And because also these documents aren't very clear in telling you, okay, if you do this, you are 100% compliant with building regulations. There is a line in approved document B in the beginning that literally says that even if you do everything within this document, that does not guarantee compliance with building regulations 2010, which kind of contradicts what I've just been saying for the past 5 minutes, but it just is that both things exist in the same environment. So you have to be a competent fire engineer that understands fully that what you have to comply with is building regulations. You don't need to just blindly follow these standards because sometimes they're incorrect. And this is the competence of fire engineers is something that is under fire these days. Well, that's a pun, but I will not spoil the rest of my talk, but there is essentially a gap caused by the demand for fire engineers, which is very high, and then the supply of fire engineers, which is very low. So then anybody could essentially become a fire engineer because there's so many jobs, there's enough for everyone, which does not mean that the quality of the knowledge is there. And I will this was a bit of a spoiler for what's coming next in the talk. Yeah, this is oh yes. So this is the framework within which we work. So how do we summarize all of these things? What we actually produce? And that is a fire strategy report. So essentially, for every building that we're involved in, we produce this technical document that demonstrates how each of these 5 points, fire B1 to B5, are done so that you could demonstrate compliance. So our fire strategy report will tell you, okay, means of escape. In this building, there are 3 exits of 200 2 meters, which means it allows for the occupancy that is being proposed. Means of warning and escape. There are no travel distances are within the lines that are specified by the relevant guidance document used. Then internal fire spread. You say, okay, structure should be 60 minutes. External fire spread. You cannot have combustibles on this. So the external facade of this building should achieve the performance of whatever standard you're using for classification. And finally, for fire service, you can have things like you're providing firefighting shafts from where the fire service can undertake their activities, or you're providing fire hydrants that are at a specific distance from the building, or no further than a specific distance from the building. So you are going bit by bit, highlighting what the performance specifications are. So as I say here, that it's a strategic report that defines the performance standards that need to be achieved. So it's not a fire safety plan. It's not a detailed construction manual. It doesn't have all the details in the fire safety system. So we're not providing an exhaustive list of, okay, this is your facade, this is what the facade should achieve, and here are all the facade design details that we've reviewed. They achieve what they have to achieve. We don't have that. We just say, this is what you need to achieve. And then what we do, okay, and this is the essentially the flow chart of how things should work. So we create this fire strategy, we outline the performance specifications, and then this informs the rest of the design team. This informs architects, MEP engineers, structural engineers, other consultants, landscaping, what they have to do or they have to not do in order to ensure that this design is compliant with Building Regulations 2010. Now they take this information, they do their designs, and then submit the information to the authorities having jurisdiction. So the authorities having jurisdiction are typically local authorities or private companies. So in the UK, I think it was in the 80s, no, not in the 80s, 90s, sorry, the 90s, the government allowed private companies to provide essentially a regulatory function and provide sign-off. So in Bureau Veritas, we also have a building control arm that does this, and approved inspectors who will sign off the building, will make sure that everything's in line. They're a separate team, so we're 2 separate teams just because to avoid conflict of interest and things like that. But they can either be private or public from the local authorities. And the reason why it was allowed to have the private approved inspectors is obviously because the local authorities, as you know, underfunded, understaffed, they couldn't keep up, and depending on where they are, also the level of competency varied. So the authorities having jurisdiction, after they receive the package, they will consult with the local fire brigade, but the local fire brigade does not have an approval. They don't have if they're not satisfied with the design, typically that means that the building control officer, the authority, the AHJ, will be hesitant to sign it off as well. But they don't have to. If the fire brigade is asking for, I think especially in line with various electric vehicle fires that have happened, the fire brigades are asking for quite onerous measures in, for example, car parks or cycle stores, understandably, but there isn't a regulatory framework behind it. So there's no guidance documents that are released by the government that you can use. So essentially the question will be, who pays for all of that? So then the authorities having jurisdiction don't have to take into account all of those more onerous requirements from the fire brigade. They are the ones who have the final say. They give you the building certificate that, here you go, your building is ready to use, safe, everyone can come here. So after they sign this off, then there is a contractor that will then undertake the construction of the building. And of course, because they don't have expertise in everything, they will then employ package subcontractors such as fire stopping contractors or a sprinkler specialist or flooring, facade, etc. And then all of those will then undertake the construction. At the end of the construction, the building owner receives the relevant fire safety information and then is responsible for ensuring that this fire strategy and the fire safety information is respected and they have appropriate management in place if that's what's needed. So yeah, this is the ideal world. This is, spoiler alert, this is not what happens. So I will say a few things that actually happen. So because I've just said that there's a lot more work than fire engineers, that means that we all have a lot of plates that we're spinning at the same time. Some have better time management than others. Some forget that their work is not in a vacuum and it actually impacts the rest of the design team. A lot of the times, our reports go out late by the time everybody else has finished their designs. So especially if you don't have good communication in the beginning with the design team to tell them from the get-go, you need all of these things, it might happen that they've done their designs and now you tell them they need sprinklers. So they haven't allowed for that at all. Now they have to change literally all of their designs. So sometimes they can't amend the designs on time. So, you know, it just carries on that way, or they have to re-amend it, and then essentially the client has to pay the design team twice because of fire engineer tardiness, which is not great. Otherwise, another possibility is that other consultants do not read the fire strategy properly. It's happened to me multiple times. I said, you need a ventilation at the stair. Yeah, thank you. I get the drawings back. No ventilation to the stair. I said many, many times. Because, you know, it's not everybody has the appropriate competency to do that. Then another issue is that fire engineers actually don't have the scope to review all the design information, because if you have to review all of the MEP designs, you have to review all the architectural details. That's just not feasible. And also, all of these disciplines are competent in their designs, so they should be the ones ensuring that what they're designing is in line with what is meant to be designed. And then the biggest issue, which is the nemesis of any sort of decent, safe design, is the design and build contract. So I'm not sure if you have that in Hong Kong. I've never heard of this happening anywhere else in any respectable country. I'm from Romania, by the way, so I can talk about that's relatively newly respectable. That essentially means that you have a design, and then when the contractor comes on board to get their own subcontractors and actually build this building, they employ their own design team, and they can make changes to that design. They can also make a start on site. So there's so many cases where they've made a start on site. They submitted the packages to the authorities having jurisdiction, who also have a big backlog. By the time they get their responses back, they've advanced with the site works to an extent that they cannot make the changes. So for example, if they need another ventilation shaft or something of the sort, and you are on site, you've already poured the cores, like you're now doing, I don't know, decoration. It's way too late. You're not gonna do anything anymore. So it's a bit of an impasse. And in addition to this, each of these, when you are on site, each of these subcontractors, so for example, the fire stopping contractor or the alarm installation subcontractor, they are all responsible for certifying their systems. So of course, they should send you the information for you to review and say, and they should tell you, okay, this is in line with, we've designed this in line with this standard, and you review it and you're like, okay, cool, great job. You can go install it, but they are responsible for certifying those systems, not the fire engineers. And additionally, I've just mentioned that the fire strategy sets out the performance. So products that you use by the manufacturers will tell you they've got a certificate, a little certificate saying my fire stopping board whatever it is, achieves the performance in line with this standard. But they don't, that's all they say. Or my material is non-combustible, it achieves class A. Great. It doesn't give you more details on that because obviously, for industry, how do you call it? Uh, your own IP, that's your product. You don't want somebody else to copy it. It's not open source. So they don't disclose that. So just from saying all of that, my question is, and the question in general, the big question is, who is responsible for fire safety? And the answer is both everyone and no one at the same time, because everyone, the whole team is responsible to ensure that the specifications in the fire strategy report are followed. But also because there's so many cooks in the kitchen, if, for example, your fire strategy specified everything correctly, and then most of the other consultants have done their work correctly, great. You've got sign off, they've done everything, they've done everything correctly. But then what's going on site is not in the sight of the fire engineer or other consultants. And they mess up there. It's their fault. But then they will say, well, why didn't the fire engineers come and inspect me while I was doing that? And the fire engineers will say, well, because that's not my job. So it's a lot of, pointing fingers. And having said that, it is 34 past. I still have a bit of time, which is great. I've set the scene for the conclusion of this talk, which is the Grenfell Tower fire. So you probably have heard of the Grenfell Tower fire, or maybe not. Sometimes I know UK likes to think everybody knows what's going on in the UK. In 2017, in June 2017, 24-story building in Kensington, which is one of the richest neighborhoods in London, caught fire, and this happened. Like, the world was watching. Firefighters were doing their best. Nobody knew how this could happen and how 72 people died and hundreds of others lost their homes. This completely shook the fire safety world. This shook the world, the whole country, as not just the fire engineering and the construction industry, but the whole country. Everybody asking, how could this happen? How is this possible? We're an advanced country. We have all these regulations in place. Like, how is this happening? And to answer that question, they founded the Grenfell Tower Inquiry, which employed a number of expert witnesses that are world-leading fire safety experts, such as Professor Jose Torero, Professor Luke Bisbee, Barbara Lane. Dr. Barbara Lane from Arup was one of the key witnesses for this. So I'll share these slides with you. They're all shareable. I've put some resources in the back of this presentation to have some like a list of all the experts that participated in the Grenfell inquiry, and then you can click on their names, and then you can find all of their reports. There's a lot of pages on the Grenfell Tower fire, but to me it's absolutely fascinating to read all of those reports and understand what happened, how it happened. It's also obviously it's really harrowing to read, especially the paragraphs that speak about how the people who lost their lives, how it happened. It's really, really disturbing, but it's very important to read that and to understand that your job makes a huge impact on actually keeping people safe. So, and in addition to the panel, I've also linked I've linked the video of all you have all of this on YouTube, all the inquiries on YouTube essentially. But I've linked the testimonials of the fire engineers that worked on this refurbishment. And I've also linked the Grenfell Tower report, which is hundreds of pages, but it also has like an executive summary and like a recommendations part, which is less huge, so you can just read that. So essentially, I'm not going to talk much about how it happened and why it happened, I'm going to talk about why it happened. This was a refurbishment. So this building was built in the 1970s. It was basically a concrete tower. I lived in a similar tower last year, and it's just, yeah, some may argue it's not very pretty. So what happened is, because as I said, this is in a very rich neighborhood, people complained about how ugly Grenfell Tower is, which Grenfell Tower is a mostly social housing tower, which is a very important detail. So yeah, they went about refurbishing it, and the refurbishments actually finished in 2016, so a year before this happened. And there were many culprits. Essentially, architects undertaking the works had never had experience on a high-rise building. They had no idea what they're doing. Fire engineer was, I think they cast like half an eye on the work. So they were not very involved. Like to their, to their, I think I view them with quite a sympathetic eye, just knowing how little importance was given to what fire engineers think at the time. Obviously, the inquiry have made the report has made their conclusions on their levels of competency and everything, but just knowing how not important fire engineers were before Grenfell, I would understand why they weren't, like, their word was not taken very seriously. Now, in addition to all of that, obviously manufacturers who were not very truthful in disclosing the performance of their products, and again, also the London Fire Brigade's lack of training and preparation for doing something like this. So it's exactly what I said in a few slides ago. Everybody's pointing fingers. So this is a web of blame. By the way, this is not my figure. This is an excellent figure, but it's not done by me. This was done by the council to the Grenfell inquiry. But I just thought that it's very important to show it, because this shows who everybody else was blaming. So whereas this is Studio E, the architects, this is one of the manufacturers, this is the fire engineer, this is the contractor, it's the government who was then NHBC, and then this was the client, Royal Borough of Kensington and Chelsea, then various consultants. So everybody was blaming somebody else. And sorry. And this, unfortunately, this fire was 100% preventable, because it was, the fire itself that happened in the flat was not something very out of the ordinary. It's just how the rest of the building responded to it. And it just really, it really captured the state of the construction industry and the fire engineering industry in the UK at the time. So it was a huge wake-up call, and it is really, really devastating that so many people died and so many people lost their homes and their livelihoods, and were entire, whole neighborhood traumatized essentially, in order for something to change. And there was also the Damn Judith Hackett report that came out of this. So that was Damn Judith Hackett was commissioned by the government or by the inquiry. Can't remember. Well, anyways, by one of these two, to give a verdict on the state of the construction industry. And she was scathing, very understandably. So there were a few things that came out of the Grenfell inquiry, the Damn Hackett report, and that is the Building Safety Act in 2022, which essentially applies to all buildings called high-risk buildings. So they're buildings that are over 18 meters high or 7 stories, which contains residential units. So this is seen as the number one thing that has to change. So for buildings where you have people that are sleeping and people that could be vulnerable. So essentially care homes and hospitals as well. This does not apply to hotels, because hotels are managed buildings, which you can't say that to all of these other types of buildings. So this Building Safety Act the main thing that's trying to address, and I think the main takeaway that Dame Judith Hackett's report had was that you need to have a culture change. You need to step up and you need to take responsibility for what you're doing. You need to be very transparent and clear in your communications. And this is, did I say that? No, I didn't say this, but they're looking to create the golden thread of information. So if you are proposing a design, fire engineer has reviewed it, great, sent it on. So essentially go back to the first figure that I've shown, this. So this is, sorry, I'm showing with my hand. This is what, a very clear path, what they're trying to do, rather than, what I said that actually happens. So stuff gets chosen as the final design, but it hasn't been looked at by the fire engineer. It hasn't been signed off by building control. It's different from that. You're just building it because you can. So have a goal, not be able to proceed with site works until you've got the relevant sign-offs. And that is, I think, one of the most important things. And I really do hope that it kills the design and build type of construction, or if it doesn't kill it, then at least, it makes it so that you can't essentially have half your building built, but you don't have the relevant sign-offs, because that, of course, money's been spent, and then we all know that unfortunately, money is what makes the world go around. So if you have to, somebody will have to spend more money for all of these delays. So the golden thread of information is the most important change that the Building Safety Act is looking to do. And they are introducing another regulator. So not the authorities that I've mentioned before, but the building safety regulator, to establish a better framework to have a clearer standards and guidance. And also mention a person that is responsible for fire and building safety through the life cycle of this high risk building. Just to give you a snippet of what's going on today, 2025, they've established the building safety regulator. Sadly, it has not introduced clearer standards and guidance. It has just made things a lot more confusing, because the government thought of doing this building safety regulator, but then didn't really think through a lot of these responses were, I completely agree that this stuff had to change, and this responsibility and the culture had to change, but culture doesn't change overnight. And very importantly, culture doesn't change unless it has to change, because the culture is driven by the money. And if there's nothing that tells you that you have to do this, this is the law, people will not, it's a very naive worldview that people will change out of their, I don't know, professional ethics or whatever. That's not going to happen. Like, some people might change, and there are companies who are very ethics driven, like Pura Veritas. We've got, every year we have to read 100 pages of code of ethics, and yes, we're very serious about it, but it's not applicable to everyone, unfortunately. So you have to provide the framework saying you have to do this, and then people will do that. At the moment, they haven't done that yet, because the building safety regulator is severely under-resourced. They haven't thought of how to resource this. The wait times are months. You submit a design, months, you don't hear back anything. The idea of Dame Judith Hackett was to have this conversation early on in the design. So have this engagement, so that when you're proposing your first design, you will get some feedback saying, okay, this is good, this is not good, this is not an appropriate level of safety, etc. But this engagement isn't happening. So what actually this has created, and I'm hoping, I'm not here to complain about Building Safety Act. I'm, hoping that it actually will succeed in its culture change, and that these are just some, teething problems while we'll figure it out. It has slowed down the construction of high-rise residential buildings. It's, if 2020, 2021, I think this was one of the main markets. Now it has slowed down a lot, because it's a huge risk, and people don't really want to invest their money in something that might not pay off, or something that will take years to build, because you don't want to spend your money on a design only for the building safety regulator to come back to you after a year saying this is not good, because then you've used all of that money for nothing. So at the moment, it's a bit of a transition period that I'm hoping, they will come out with more clear guidance and standards. I'm 47 past. And then, in addition to the Building Safety Act, There's also been the Grenfell inquiry recommendations that the report that came out in 2024. So they've been 2 phases of the Grenfell inquiry, and the phase 2 reports came out in September. And it looks at it's got recommendations for everyone in the industry, but I've put here the ones that they say about fire engineering specifically. So they say what the fire safety strategy should have. It shouldn't have. It should be comprehensive. It should state everything that the building needs to achieve, and also they recommend that it's going to be a statutory requirement. So essentially, you must have a fire strategy report by a registered fire engineer submitted to the authorities having jurisdiction. So it's not like you've already started on site, you don't have a fire strategy. You can't have that. They're reinforcing that you have to do this in a timely manner. And regarding fire engineers, they say that they recommend that the profession of fire engineers be recognized and protected by law, and that we would have an independent body to regulate the professions, define the standards required for membership, and maintain a register of members. So what we have now are a few institutions. At the moment, the main thing you can do to demonstrate your professional competency is get chartered with the Institute of with the Engineering Council, and then you have multiple examining boards for that. And the Institution of Fire Engineers is one of them. The Institution of Fire Engineers is meant to be this body, essentially. However, the Institution of Fire Engineers is not, again, similar to the building safety regulator, it does not have the resourcing. And at the moment, if you submit your chartership application with them, you could wait up to a year to hear back, and they give you no feedback in the process. So it just takes a very, very long time. And you have pockets of engineers that are chartered with the IFE in various companies, because if you have somebody that is chartered with the IFE, they will tell you and help you and know exactly what you have to do to get your chartership through. Do I sound bitter? Yes. We have 3 chartered engineers. They're all chartered with other institutions, not with the Institution of Fire Engineers. We're a bunch of us working on this, but because of the duration that it takes for our chartership applications to be reviewed, we might actually go other routes that are equally, essentially you're chartered with the Engineering Council. That's what matters, and all the other examining boards are relevant to this. So it's not just the Institution of Fire Engineers. So essentially, the Grenfell Inquiry recommends that we do have a new body that can do that, and also that the development of these professional skills, in the meantime, while we get that body developed, the government should convene a group of practitioner and academic fire engineers to produce a statement of what is expected of a skilled, competent fire engineer. At the moment, we don't have that. We have people getting into fire engineering from various routes. And to be honest, I didn't do a fire engineering undergrad. I studied civil engineering, and then and then I went to do my PhD in mechanical engineering, but it was fire-based. So, theoretically, I have an undergrad in fire engineering, and there's not a lot of fire engineering courses in the UK either. You have the course in Edinburgh, obviously the masters, and then a course at the University in Central Lancashire. So there's also a master's at UCL that Professor Torreira has put together, but that's more orientated towards professionals, I think. So there isn't really a strong fire safety program like there's many in the States. So this really has created a gap in how you can become a chartered fire engineer. There's people coming to fire engineering from various engineering backgrounds, which is great, but you also have fire engineers becoming fire engineers after a long time in the fire service, which is a very important skill set, but sometimes there's things that you might not be aware of, or through the fire risk assessment route, which again, a very different route. So what the Grenfell Tower recommends is that Grenfell Tower Inquiry recommends is that we need to have a set statement telling you what is a competent fire engineer, what should we aim for. So yeah, that was me. As I said, I will send this to you guys. Oh, somebody has drawn on my slides. Love that. Um, and you guys can then just watch these or oh yeah, and I also have put a link to the Building Safety Act, so you can read more about it. So yeah, that's been me. Thank you very much for your time. We have 10 minutes if we can have a look in the chat, or if anybody has other questions. That's great.
Yes, so far, thank you, Isabella, for very detailed talk. And so far, we have only one question in the chat room, so I'll read that. So, are there any special considerations for certain types of buildings, such as like historical buildings?
Yes, so there is none of the guidance documents that I've mentioned, they don't have a part in them where they say, well, for historical buildings do this, but rather there's more of an engineering approach on them and understanding, okay, if you need to work within the constraints of the existing building, you need to maintain like historic things about it, such as the facades, which is typically what is the most retained. And then you think about you either, yeah, that's where most performance-based design happens. So you would do CFD models, you do evacuation modeling, you do, or just, yeah, zone models, whatever you'd need to see how that building would perform in case of fire. And a lot of the things that people use in these situations are more active fire protection measures. So you'd either the installation of sprinklers or water mist or whatever other gaseous suppression, whatever's needed. Of course, not in the members of the public. Would also use stuff like fire curtains or detection alarm systems that are I don't know, zoned or something. So yeah, that's that
Yeah.
would be the consideration. But again, those considerations are chosen by the fire engineer. So by, again, competency is something again that is important. So you know what you're doing.
Okay, I use the chance to ask one question. That you have mentioned a lot of things about the fire engineering practices, also education training. And of course, there's a lot stakeholders and parties plays the role or to be blamed for the Green Fire Tower. And design is one of the one part, not everything. So I guess even you have the best fire engineer do the best design, some kind of fire may still not be prevented completely. So what others, I mean, you think can be improved together with better training of fire engineer, better qualification of fire engineer. So together may generate so 1+1 more than 2, something like effect.
Yeah, I think that's the question. So I think, yeah, say you have the best trained fire engineers, the design is complies with everything. It's a very good design. It then it's also the culture that has to shift. So the contractors have to be like, okay, the works that we're doing on site, if the fire engineer should monitor them, they should come and see that we're actually putting it on site. But what does that mean? It means that we have to pay the fire engineer. They're not coming to site out of the goodness of their heart, because ultimately they need to make money. So we are going to pay them for that because that's important. They need to come and see and ensure that what we're building is correct. But if they don't have to do that because the law or the whatever regulations don't say that they have to do that, then they're going to be like, well, we know what we're doing. Bye. So it's all about actually valuing and understanding, and it has to be throughout the construction industry. Also, especially subcontractors have to understand how their works impact the rest of the building. So it's really yeah, it's a big shift, and it's throughout the industry.
Thank you. And we have a follow-up questions. So what course and skill do you think fire engineer or master program, PhD program need to include to make things better?
I think, in my view, I think, having a bachelor from any sort of engineering discipline and then having a master's from a fire engineering is sufficient to understand the main principles. So you have to understand how fire works. You have to have good knowledge of fluid mechanics. You have to understand things like ignition, things like fire spread, fire dynamics in general. You have to, because a part of, there's been many engineering judgments done, but like people don't actually have the engineering skills to do those judgments. They just say that, well, if this this gap is 20 millimeters, well, if it's 25 millimeters, it's almost the same, so it should be fine. But actually, what are you basing it on beyond this should be fine. So definitely fire dynamics is, in my view, one of the most important things that you can learn. Obviously, some structural fire safety as well is important, but fire dynamics is understanding like fluid flow, understanding ignition. These are very important.
Yeah, from my point of view, I feel it's really hard. I mean, fire dynamics class is really hard.
It is.
I mean, even you get a high score in the exam, you may still only understand very small portion of it. And so it's, even for me, I keep learning new things.
And I think you've answered the question there. I think by going to all of these, by having all of this knowledge, and I mean, you're a professor, you've written hundreds of papers, you still, the biggest takeaway is that you don't know everything. Whereas somebody who doesn't have this knowledge, they're like, well, I know this is clear, and that's not true. You have to know your place. You have to know that actually there's a lot you don't know. So you can't just say that should be fine.
Thanks. Some new questions. So does the government tend to reduce safety fund and attention during the accident-free period until a new accident happens? So it's more like a disaster-driven regulations. How do we?
100%. That's exactly what happens. I think people just have to remember, you know, I mean, I don't want to get too political here, but I think when something is gone from sight, you think it can't happen again, but actually it can. And I think it's again talking about the culture shift, that it shouldn't be just. In Romania, we had a fire in a nightclub in 2015, and a lot, like 50 people died, I think. And then what happened this year? There was this fire in the Balkans, literally exactly the same thing. Like people did they learn? No, they didn't, because they didn't have to. The government was like, well, it's happened, it's not happening. There isn't. I think the answer to all of this is nobody is responsible. Nobody's afraid that if anything goes wrong, it will be on them. They're just like, well, it's not me. So yes, it's very much reactionary. So it's just, okay, this happened, we have to do something. Whereas the correct approach would be, let's make sure that doesn't happen. So I think at least what we should do is learn from what has happened already. But unfortunately, we're not even doing that. So yeah.
Yeah, I guess if someone is taking the responsibility, then he probably wouldn't sign it.
Yeah, exactly.
This might be too long.
Yeah.
You can never move things forward.
Exactly.
Okay, another question. So in UK, any original method, calculations or data can be found, which regulation or standard are based on? Sometimes we should design a new file service system with another approach, such a engineering approach.
Yeah, so yeah, if you can't comply with the regular standards, so if you need to do some further calculations, further data, you need to provide good referencing. And typically the British standard 7974 has references to, I don't know, the SFPE handbook, ignition handbook, all of these like key documents that we've been using for years. But if there's something that's not there, you could also use new research or papers or things like that you have the knowledge and you know about them. But the difference, or the issue that could arise from that is then you have to have your strategy signed off. The authorities have to approve it. And the thing is, if they don't have the knowledge, they don't have the competency to understand what you're proposing, they will say, well, this isn't in line with the approved document B. I don't know about this. So it's also them having the knowledge and understanding what engineering actually is. So yeah, that's the challenge with when you do your own, when you use research and calculations. Not saying it's not happening, because it is used, but it really depends. It depends on project to project, and yeah.
Thank you. I think that's a perfect time to end today's talk, and really appreciate it for your sharing. I think our local engineer probably learned some insights from your sharing.
Thank you so much. Thank you for having me. I hope it's been helpful, and I will send you the slides so you can distribute them so people can have links and things like that.
Okay, so that's the end of today's webinar. Thank you, everyone.
Thank you. Have a good weekend.